Hi, I'm Jason. Welcome to week 3. So last week we studied the poultry problem. You learned that the original solver, I use that loosely, of the problem only considered the addition of sensible heat. They used Q equals mc delta T, where the heat addition equals the mass times the specific heat capacity times the change in temperature. The biggest piece they missed is all the heat that has to be added, the change in enthalpy, to thaw the chicken, to drive the phase change from ice to liquid, from solid to fluid. I mean, even if we ignore clearly you're not going to cook a chicken to 400 degrees Fahrenheit. So we make an assumption that we're going to go to 165 degrees. If we consider all these other assumptions to be ideal processes or minimal and just ignore them and only look at the direct conversion of kinetic energy to thermal energy and assume that all that heat goes into the chicken, the result is still multiple times off of what they had originally solved. Anyway, what you really learned is an example, what you studied was an example of a thermodynamic process, right? So there's a substance that's in a state, and one or more of those properties of that substance change. Temperature, pressure, volume, something changed. In this case, the enthalpy, right? Well, temperature and then enthalpy and then temperature again. Well, that's what we're going to look at this week, are other examples of thermodynamic processes. So you're going to have to brush up on what your definitions for adiabatic, isentropic, isenthalpic, and I was going to say and throttling process, but that throttling process is an isenthalpic process. So yeah, isenthalpic, isentropic, and adiabatic. So here's a fun fact. 3 Mile Island. Some of you, I had in my last class, and you studied accidents, nuclear accidents, and one of them was 3 Mile Island. So 3 Mile Island was a pressurized water reactor. So it's a little different than what we have out here at Columbia, but it's the same type of design. Not the exact same manufacturer or anything, but the same idea, used on submarines, on aircraft carrier, what was on the cruisers back when we had nuclear cruisers. And it basically has 2 different loops. It has a closed primary loop where there's never any boiling. So it's always pressurized water that never boils. Well, we learned last week that steam is able to because when we add heat and have that phase change, we end up with steam that has a lot more energy, a lot more ability to do work. And so a pressurized water reactor is a little less efficient in that way, right? Because they only use the reactor to take hot water and heat it up to hotter water, but it's always pressurized. Well, anyway, they had a problem, and they had a relief valve lift. Now, a relief valve lifts, there's a change in state of that water that's coming out of that relief valve, and it's a throttling process. And that throttling process is an isenthalpic process. It means that though you're changing the entropy, though you're changing the moisture content, the quality of that water steam mixture, because it's going from high pressure to low pressure, so it's flashing off into steam through this throttling process. It's really a complicated minor process, and the operators at the time, and we're talking 3 Mile Island, they didn't understand what they were seeing with that relief valve. They thought it had closed, when in fact what they were seeing were indications of a stuck open relief valve going through an isenthalpic throttling process. These processes are extremely important because of examples like that. Now, next week, we're going to put these different processes you're going to learn together into a cycle. This week is processes, next week is cycles. But we're going to start looking at each of these processes independently. We're going to look at, well, that phase change again. We're going to go from subcooled liquid, and when I say subcooled, I mean we're still going to be talking about 300 to 400 degree Fahrenheit water, bring it up to saturation pressure for 1,000 pounds PSIA, boil it off, so it's going to go through a phase change, and then it's going to go into a turbine, and then it's going to do work, and then we're going to send it through a condenser, and we're going to cool it off and condense that steam back to liquid. And now we go from so we're going to end up completing the cycle, but we have to understand what's going on in each of these processes first. So this week I want you to pay attention to pumps, right? Because pumps add energy to a system. It's work done on a system. When we look at our general energy equation, we have all these different terms: potential energy, we have kinetic energy, we have flow energy, we have internal energy. And of course, we talked last week that internal and flow energy are combined. That's the enthalpy. But we also have the work done on or by the system. So a pump does work on the system, whereas a turbine is work done by the system. So these two processes compete with each other, right? And then we have the phase change from a fluid to a gas, to a vapor, and then the condensing of the steam from a vapor to a fluid. And so those two processes are competing with each other. And we're going we're going to start with that subcooled liquid, and we're going to add heat, we're going to add energy to the system. We're going to do work on the system with the pump. And we're going to raise its pressure and its temperature, get it to the saturation point. We'll go through the phase change. And then we're going to do work on use the turbine to do work. And then we're going to go through the condenser and back to a subcooled liquid. So subcooled liquid, steam, superheated steam, do some work through the turbine. So your evaluation method for this week is going to be a quiz. I'm going to make that available for you on Thursday. It's not going to be available right now. I want to give everybody several days to go through the material, and then I'll make the quiz available on Thursday. So you're going to read pages 54 through 72 of your student text. Pay attention to those processes I described. Pay attention to the pump process, to the turbine process. Pay attention to the boiler, which is the conversion, which is where the phase change happens, going from a liquid to a vapor. Pay attention to the condenser, which is where the phase change happens, going from a vapor back to a liquid. We're going to talk about valves and nozzles. So once again, that throttling process. And when you're looking at each of these processes, pay attention to where they fit on the general energy equation. So to help you prepare for your quiz, I included a couple links on the overview page, but I don't want you to get too worried, because there's just a lot of tough questions in there, and there's some of those topics we're not going to get in as deep into. So this is where I want to help calm some fears. Last week was a tough week, yeah, but it's the base block for all the rest of these weeks. So the rest of these weeks aren't going to be as tough, because we're really just going to be building on all that information we learned last week. That doesn't mean they're going to be easy, but we're definitely not going to be going, the same level I teach my general fundamentals classes at as preparatory for going into a licensed operator course. We're not going to be teaching second or third year thermodynamics. This is all going to be introductory, conceptual, mostly conceptual. I do expect some practical applications of it. but mostly conceptual on these ideas, so that in future classes, for future levels of thermodynamics, for those of you that are going to be operators in one of my classes someday, you will then have a base understanding as we start calculating more of this stuff. So once again, make sure you're using that questions for the professor. Some of you have texted me, some of you have emailed me, messaged me. All of that's fine. However you need to get a hold of me to let me know both what's going on with you, what can I do to help, and what are you confused about? Because I'm looking for opportunities to do focused videos. I got a lot of good feedback on that one with Jim Tansey, and he's asked to do more. Before that even happened, I already have another one set up for when we get to pumps with super instructor Zachary Robinson. I'm excited to see that one. That he's a fantastic instructor. I've got a couple of demos I'm still working on. For example, I'm working on a video for next week when we start talking about cycles, showing an entire thermodynamic cycle. So a process of expansion and contraction in a gas. So I bought one of these Stirling heat engines. It's been quite fun. So right now I'm just mostly trying to figure out how to shoot video on this. I suck at doing these videos unless it's just static like this. But yeah, this one ought to be a fun one. So let me know what you need help with. Let me know what you want me to talk about. Make sure you get your assignments done early, get all the reading done early, watch the videos, and be ready for the quiz on Thursday. All right. I hope everybody has a great week. Talk to you again soon.